Hello, my name is Whine. Thank you guys for tuning in to Memphis Communiversity. I hope it's very helpful. Today I'm going to be working on the derivatives of trig and inverse trig functions. Definitely not the most fun thing of calculus, but they're very important and very often used, so I hope I can help you guys out. If you're interested in doing these worksheets alongside me, the worksheet along with the answers to the worksheet are linked in the description. So feel free to download them and work it with me. Right now, I am just writing out all of the trig derivatives that you'll need to know. Honestly, there's no good way to remember them. You just have to memorize them. Not super fun. These can all be proven, but honestly, you don't need to know that, or at least I didn't. So I'm not going to explain them. I'm just going to write them all out, and that way we can reference them when we're working the problems, and you can see where I get all of the derivatives from. So you can, I'm sorry if my little recorder thing's in the way. There we go. So you can see them and I'll reference them when I'm working out the problems. Here's one helpful tip that did help me when I was trying to memorize them. A lot of trig functions start with cosine, cotangent, all of those, and all of their derivatives will have a negative in them. So as you can see, cosine's derivative is negative sine, and cosecant's derivative is negative cosecant cotangent. So that trend will continue in all of the derivatives. So that is just one little helpful tip. They kind of come in pairs, one being negative and one being positive, and the cos are always negative. So if that helps you guys, I hope it does. It helped me. I'm just going to speed through me writing the rest of these because they're very basic. I'll reference them when I work the problems, and sorry if this cuts out. And so it'll be very easy to remember them. Okay, there. Okay, so here's the first problem. The function is 3 sine x plus x squared, and we're trying to take the derivative of it. So first things first, so 3 sine x. If you have a number times a function, in order to take the derivative, you just write the constant, which is 3 in this case. That doesn't change. That does not change when you take the derivative, so it's just a constant. It's still there. So what we're going to have to do is take the derivative of sine x. As I reference, the derivative of sine x is cosine x. So it's 3 cosine x. And then we have to take the derivative of x squared. For x squared, you use the power rule, which entails bringing down the power to the front and then simplifying. So you would drop the 2 to make it 2x, and then subtract 1 from the exponent. So 2 minus 1 is 1, so you don't really have to write an exponent of 1, so it's just 2x in this case. And since you add them together, there's no product rule or quotient rule, they're completely two different derivatives, so you don't have to worry about that. Yeah. Okay, so the next question, don't be freaked out that it's theta and not x. That doesn't change anything. It's just another variable, so don't worry about that. So moving on to the problem, 2 tan theta minus 4. We're taking the derivative of that. So like I said before, a constant is simply a constant. You don't have to change it if the derivative is being taken, so you leave the 2. So then we have to find the derivative of tan, which I had written out to the side. It's the derivative of tangent is secant squared. So you just simply replace tangent with secant squared, continue to put the theta because that's a variable. And then for constants without x's, so like this 4, it's just a number, all derivatives of just numbers are 0. So the 4 would turn into a 0, it would disappear. Yeah. So those hopefully haven't been too bad. So the next problem is g of x equals 5 over x plus cosine x. So I rewrote 5 over x to make this a little simpler. Because you still have to use the power rule, except it's a negative exponent, so I wrote it out with the exponent to make it a little more simple and a little more intuitive so that you guys could see it. I do this whenever I'm working out problems, so I think it's really helpful just to keep my mind straight, to help me remember what I'm supposed to be doing. So now we're going to take the derivative of this. So like I did in the last problem, or I guess in the number 1, we have to use the power rule. It's a negative exponent, but don't be freaked out. It's the exact same. So 5 in this case is a constant because it's attached to a number. So the 5 stays the same. You just continue using the 5, but it becomes negative because you have to drop that negative exponent. So you drop the negative 1 down. So it's really 5 times negative 1. I wrote it out as negative 5. So you have negative 5, and then you have to subtract 1 from the exponent. So negative 1 minus 1 equals negative 2. So that is the derivative of the first part. And then we move on to the trig part. So the derivative of cosine, as you see right there, as I'm referencing, sorry, I paused it, is sine x, is negative sine x, excuse me. I replaced that plus sign with a negative sign because all derivatives of co-trig functions are negative. So it turns into negative sine x. Not too bad, I hope. Number 4. So number 4, the function is secant x plus inverse secant x, or arcsecant x. You'll hear both. You'll see it written out as both. So this one, not too bad. It's literally just the trig identities that I wrote to the right. So it's secant x. The derivative is secant x tan x, or tangent x. So that's not too bad. You just have to memorize it. I'm sorry, it's not fun. And then I'm sorry you can't see the derivative of inverse secant x. It's cut off by the screen, but the derivative of inverse secant x, it's kind of long, is 1 over x times the square root of x squared minus 1. I'll write it out here, but once again, it's something you just have to memorize. The inverse ones get a little more hairy than the normal ones, but I promise you guys can do it. It's not too bad. And that's simply it. It's just writing out 2 trig derivatives. Nothing too bad. So number 5. Oh yeah, see, I put it out right there if y'all can see it. Number 5, the function is f of x and y is the same thing. So don't get freaked out by that. And as you can see here, just like with the negative exponent on number 3, I am rewriting the square root as x to the 1 as 4x to the 1/2. So I can use the power rule. You still have to use the power rule, so I just find it a lot easier to actually identify the power so that you can really understand it and be able to not make any careless mistakes. Those are the worst. So as you can see, I can't remember if I write it as 4 times 1/2 or I just write 2. But what you would do is you would drop the power. Yeah, so you drop the power 1/2. And then 4, as in a lot of other problems, is a constant, so you leave it the same. And then, as you can see what I'm about to do, you have to subtract 1 from the power. So 1/2 minus 1 turns into a negative 1/2. And of course you can simplify that as 2. I just wanted to explain it to you guys so that you could see I was clearly dropping the power. And now we're moving on to our trig part. So like sine and inverse sine and secant and inverse secant are just completely different. They have the same word, completely different, so don't get confused. So now you just have to really just write out the derivative of inverse of sine. You have to memorize it. It is 1 over the square root of 1 minus x squared. And don't get confused. This derivative is not negative. It's not a but it's just negative because it actually starts with a minus sign in the problem. So don't get confused by that. I know that can be kind of tricky, or I thought it was, at least. Yeah, as I point out the derivative. Okay, number 6. I hope this is helping you guys. So number 6, this is just another kind of derivative we have to memorize. The derivative of the natural log ln of x is just 1 over x. That's just one you have to know. So in this problem, 4 is a constant. Like it is with all the other ones, it's attached to a function, so you just leave it the same. It's just 4. And then 4 times 1 over x, I just wrote as 4 over x. So for the second half of the problem, 2 is once again a constant because it's attached to something with an x in it. So I just wrote it as the numerator of the fraction of the derivative of inverse of cosecant, which is right here, as I might have pointed out, can't remember. But this derivative actually is negative. Keep that in mind. It is a cosecant. So this negative sign actually turns into a plus sign. So make sure to keep your sign straight. It can be kind of confusing. But you don't want to make careless mistakes. Okay, number 7, sorry. This is the best function, by the way, guys. The derivative of e to the x is simply e to the x. Yay. Sorry, that was cheesy. But so 4 is once again a constant, so it just stays the same, and then e to the x stays the same as well. So you don't have to worry about that. And then we'll move on to the next part, the derivative of cotangent. So 6 is a constant, like all the other constants I've been explaining. I believe you guys got that by now. Sorry, I keep saying it. But the derivative of cotangent, you have to memorize this, is negative cosecant squared. Remember, it's negative because there's a co in it. So remember that plus sign changed to the negative sign. And then it's just the derivative. Not super exciting. Okay, number 8. Once again, don't be freaked out that it's a theta. Nothing really super scary about that. So this is just another derivative you have to memorize. So the derivative of 6 to the x, or 6 to the theta, or 6 to whatever variable you're using, would be the constant to the x, so 6 to the theta again, times ln of whatever the constant is. So in this case, it's 6 to the theta times ln, or natural log, of 6. I don't know how to write on here. This is my first time doing this, but maybe I can do it. Here, let me see. So the just the generic derivative of this is a to the x times L and the natural log of a. Wow, that's really bad. I'm sorry, guys. I didn't mean to do that. I don't know what, okay. You saw me write it out, though. I didn't mean to do that. But that's the generic formula of the derivative. So in this case, the a is 6 and x is theta. So that is the formula for that kind of derivative. But we're talking about trig on this, so I'm going to move on to the trig part of the problem. So as I said, the inverse of some of these trig functions can also be called arc. So cosine to the -1 equals the same thing as arc cosine. So don't be freaked out by that. It's just jargon. So 5 is a constant, as there have been constants in every other problem. So yes, there's the derivative. Keep in mind it's negative, so that minus turns into a plus. And then you just write down the derivative. I put 5 as the numerator because it's the constant. So, but you could put it to the side. It's whatever you want to do. I just simplified it a little bit. Okay, next page. I really hope I straightened it out. I did. Kind of. Okay, hold up. I got to drag. Sorry if you can see my paws. Okay. So number 9, on these, I did not have the derivatives written out to the side. They're still the same. You can look them up. Hopefully you can try and memorize them. But I just didn't want to rewrite them twice. I believe in you guys. So we're going to start with number 9 now. So don't be freaked out by this one. It has a little bit more complicated things, but don't worry about it. So like I said, e to the x, e to the t, e to the theta, e to the anything stays the same. Thank goodness. And 2 is a constant, so it stays the same too. So 2 e to the t simply stays the same, 2 e to the t. Don't worry about that. And then we move on to our trig part of the problem. So it turns into a plus sign because remember all cos are negative. And then 6 stays the same because it is a constant. And then you just write in the derivative of inverse cosine, which is 1 over 1 plus, or negative 1 over 1 plus x squared, or in this case t, because that's the variable we're using. Once again, you can memorize that. And then this is just a very easy derivative. I'm sure if you're on trig derivatives, you've done this before, but you can view it as the power rule if you want. It's t to the 1, so you drop the 1. So 1 times 9 still is 9, and then you subtract 1 from the power, 1, so it's 1 minus 1 is 0, so it turns into a 1 and it disappears. So all of that basically saying that the t disappears and it's just 9 now. So it becomes just a number. The t disappears. Okay, number 10. I don't know why I'm pausing. Okay, so like I did on the previous page, I'm writing out this fraction in form of its power. So instead of writing 1 over t to the third, I'm going to just t to the negative 3. This makes the power rule easier, like I've said before. So now I'm just going to do the derivative. So negative 3, drop the power to make it a constant, the variable, and then negative 3 minus negative 3 minus 1 turns into a negative 4. So you could turn that back into a fraction. I don't think I did. I usually don't. My math teacher never made me simplify. I'm sorry if yours does. But it would simply be negative 3 over t to the 4th. In a similar format as you saw in the problem with 1 over t to the 3rd. And now I'm going to move on to the trig part of this, which is what I'm supposed to be talking about. So you just have to memorize this again. I'm sorry, I know this one isn't very fun. 2 is a constant, so you pop that on top. The derivative of inverse sine is positive, so the negative stays negative right there. And then you just plug in the derivative, which is 1 over the square root of 1 minus x squared, or in this case, t squared. Yep. Okay, now we get on to the harder things, but not too bad. I believe in you guys. You got this. So for tangent line equations, anytime you have a tangent line question, sounds intimidating. It's not that bad. You need to know 2 things, and I'm gonna write it out right here. Let's see. Okay, yeah, tangent line. So this is a very common type of question. What you're gonna need, let's see if I write it out. Yep, point and slope. Oh, I'm gonna let myself finish writing it. Point and slope. So these are the 2 things you're gonna need in order to form an equation. And what's really important about the slope is that the slope is the derivative of the function that you already have. So as you'll see me work it out, I'm going to do it, but I'm just going to explain the process up front so you can hopefully follow along with what I'm doing. So what you do is you have an x, and in order to find the point, what you'll do is you'll plug in the x value to the equation you're given. So you'll plug in 0 to this y equation, and then you will get a point. You'll get 0, comma, something if you plug that in. I'm going to do that later, so I'm not going to do it right now. And then in order to find the slope, you're going to take the derivative of the function. So y prime, you're going to find y prime and plug in x into that, and that will give you your slope value. And then with a point and a slope, you will form a tangent line equation. So not too bad. So I'm going to work out a couple for you. Hopefully I explain it well. Yeah. And then you're going to write the equation in the point slope form. It's the easiest form to write. I'm really sorry if your math teacher makes you write it in a more complicated form, because the point slope method just spits out a point and a slope, and then you can write it in a point slope form. So super easy. All right, I'm going to stop babbling and work the problem. Okay, yeah, so slope is derivative. Okay, so like I said, what we're going to do, I might take a minute doing this, and I'm sorry if I do. So what we're going to do is, yep, I don't know what I'm doing in this one. Okay, so you are going to plug in 0 to the y equation. So that's what I did right now. 5 times 0 plus cosine of 0. So 5 times 0, easy. You might be asking, what the heck is cosine of 0? Good question, because I didn't know either. So I'm going to have to draw the unit circle. And so the angle 0, I'm highlighting, or I thought I was highlighting. I'm going to in a second, or drawing over. The angle 0 is just the right, I guess that's not right to you guys, the rightmost part of the unit circle, or coordinate system, and the point that corresponds to that is 1, 0. So the point is 1, 0. So you might be asking yourself, is it 1? Is it 0? What does that mean? And that's a good question. So in, what's it called? In a point, the x value is the cosine and the y value is the sine on the unit circle. So the x value would be the cosine. So the x value is 1. And then the y value is sine. We're not using sine right now, but if we were, sine of 0 is 0. Cosine of 0 is 1. A lot of people know that. That's pretty common, but this is just kind of the derivation of it so you guys can understand and hopefully do it for more angles in the future. So 5 times 0 is 0. So you get 0 plus 1, because cosine of 0 is 1, equals 1. So your point would be 0, 1. Not too bad of a point. Not too complicated. Okay, this gets to the more complicated part. Still not too bad though. Don't stress. So you're going to take the derivative of y. You're going to find y prime. So this is not too complicated of a problem to take a derivative. So it has, as I explained, the big T nonsense up here where I was doing the power rule and all that stuff. Basically, if there's no exponent on an x, it just drops away. So you get 5 plus negative sine x, because remember, co's are always negative. So it's really 5 minus sine x. And then you're going to plug in 0 into that so that you can find the slope value. So as I was explaining up here, the sine of 0 is 0 because the y value corresponds to the sine part. So as you'll see, the equation simplifies to 5 minus 0 equals 5. Yay. So now all you have to do is write the equation. The easiest part, as long as you don't have to convert the equation. So you get the point slope form equals, the point slope form is written y minus y1 equals slope times the quantity value of x minus x1. So here it is, let me just write it out and then I'll explain it. I can't see because of my hand. Okay, so here, so y, that's just the constant, and then minus y1, we found y to be 1, so y minus y1, so y minus 1, equals the slope, which we found is 5, and then x minus 0, because the point turned out to be 0, 1, so 0 is the x value. You could just write 5x. I just wrote it completely out to demonstrate to you guys what the point slope form is. And I mean, it's not wrong if you leave the 0 there to make the form a little more complete. So either way, it's up to you. But of course, if x is not 0, then you do have to include the number. Moving on. So next problem. So once again, same exact process. We're going to find the point and the slope. So we are going to plug in the x value, which is pi, into the y value equation in order to find the y value of the point. So it would be at 8 sine pi plus 5 cosine pi. And if you don't know the values of sine pi and cosine pi, which is totally fine, you once again have to draw the unit circle. So pi on the unit circle is 0 is on the right, pi is on the left. So the point is 0, negative 1. So, like I said before, the x value is cosine and the y value is sine. We'll be using both of these since the equation contains sine and cosine. So, I'm going to write it out, so I'll just let you see it then. So you're going to plug it in. You're going to get 8 sine of pi, which is actually -1. Oh, wait. Sine of pi, sine. Okay, after a brief pause, because I confused myself, I realized that I wrote the point wrong. So I'm not going to accidentally erase my drawing like I did last time. The point is actually -1. Sorry, that kind of runs together. 0. So that's the actual point. Just forget that. That's wrong. Sorry. Okay. So when you plug in the correct point into, I'm so sorry, guys. When you plug in the correct point into, the y equation you're given, you will get, so 8 times sine of pi. Pi is the y value, so you'll get 0. I don't know why I'm not writing this. Okay, I'm sorry once again, guys. Okay, so in order to keep the video going, I cannot be drawing on it. But, as I said before, the point is actually -1, 0. So ignore this. I can't draw over it. Maybe I just don't understand how this program works. But, so point is actually -1, 0. So when you plug it into the y value, you will get 8 times sine of pi, which is actually 0. So you will get 0. Oh, sorry. That's fine. So you'll get 0. And then for the next one, 5 times cosine of pi, which, ignore the wrong point, that's wrong. You'll get 5 times -1 equals -5. So 0 plus -5 equals -5. So your point is going to be pi -5. I'm so sorry that was so complicated. Please don't lose faith in this video. So same way you do the slope, you find y prime, or the derivative of the y equation, and we're going to do that using the same trig identities and equations that we've been using on the first problems. So the derivative of sine x is simply cosine x, so you're going to get 8 cosine x, and then the derivative of cosine x is simply, remember negative sine x, so you're going to get -5 sine x. Not too bad. And so you're going to plug in pi again, and using the correct point, not this, wrong point, it's actually -1, 0. You're going to plug in this point into the x's, so you're going to get cosine. Cosine is the x value, and then I'm so sorry. So cosine is the x value, so it's 8 times -1. So you'll get -8, and then cosine of pi. So you're just plugging in pi. Sorry, got ahead of myself in the video. Times -5 sine pi, not x. And then, so now you're going to plug it in. I'm so sorry. I lost myself. I promise I'm going to pick it up. -8 plus sine of pi, as you saw here, not here, the correct equation is 0. So I just didn't write it, but you could. So now I'm writing out the point and slope form again. So you get y plus 5, because the 5 here is negative. So remember, the format is y minus y, so since it's minus minus, you get a plus. Slope is -8, we got from this. And then x minus x, the point, the x value and the point is pi, so x minus pi. Cool. Okay, moving on. Hopefully this one will go a little better. Sorry, guys. I feel really bad. Once again, you're doing point and slope. So you're going to plug in x into the y equation in order to find the y value of the point. So you get 4e to the 0 plus 6 inverse tangent of 0. Okay, so quick pause. Remember that e to the 0 is 1, not 0, not 0. Just as any constant to the 0 power is 1. So 5 to the 0, 7 to the 0, 4,700 to the 0, all equals 1. Don't get that confused. It'll really throw off your equation. So now we are going to find the inverse tangent. You might be like, dang, how do you do that? That's a good question. Okay, sorry if there was a little glitch. I had to refresh myself on the inverse of tangent because I am not super awesome at trig either, but I want to help you guys. So I reminded myself. Okay, so the unit circle angle that I just I drew because it contains tangent. Tangent equals y over x. I know we're dealing with the inverse of tangent, but just bear with me. So tangent equals y over x, or sine over cosine. You also may know it that way. So sine over cosine, or y over x, in this instance is 0 over 1. So the tangent of 0 equals 0 over 1, which, as you guys know, equals 0. So the tangent of 0 equals 0. Very nice. Yay. Okay. I'm going to write this out for you guys because it really helped me when I explained it like this. So the tangent, I'm so sorry, my handwriting is like really bad, of 0 equals 0. So I'm also going to compare this to just the tangent of A, that's an A, equals B. So in order to find the inverse tangent, the A and the B, the X and the Y, switch. So you would get the inverse tangent, so you add the little -1, of B equals A. So in many cases, this would change the number. But since we're working with the equation tan of 0 equals 0, this also means that the inverse tangent of 0 equals 0, because they switch, but since they're the same number, doesn't really affect anything. Okay, I hope that helped explain this to you guys, because I got confused for a second, so I wanted to go check my work so I could best explain it to you guys. Okay, so we're plugging in 0 now. So I plugged in 0, and now we're actually going to solve it. So, like I said a couple minutes ago, e to the 0, anything to the 0, 47 to the 0, 56 to the 0, anything to the 0 equals 1. So you're going to get 4 times 1, or just 4. I actually wrote out, yeah. Okay. So, as I said in that big, long, confusing explanation that has since disappeared, the inverse tangent of 0 equals 0. So, you ultimately just get 4 as the y value of your point. So, your point is 0, 4. Beautiful. Okay, now we're going on to the slope. The slope, as I said, is the derivative, so it's y prime. So, we're going to take this derivative. I already did the first part because the first part is super easy. E to the x, the derivative of e to the x is always just e to the x. So that part doesn't change. Now we are going to take the derivative of the inverse tangent. 6 is a constant, don't worry about it. And the inverse tangent, you just have to memorize the derivative of. It's positive because there's no co, so you get 6 over 1 plus x squared. So that is your slope, or that is your derivative. In order to find your slope value, you have to plug in x, which is 0. So you get 4 e to the 0 plus 6 over 1 plus 0 squared. So e to the 0, 1, so you get 4 plus 6 is 10. I don't know why it took me so long to do that. So it doesn't turn out being that bad. So your equation, point slope form, so y minus y, so y minus 4 equals the slope, which you found is 10 through the derivative, x minus 0, or just x, however you want to do it. You do you. Okay, the next one, I will warn you, gets very triggy and tricky, but I will do my best to explain it for you guys. So the format is still the same. You're still going to find the point. You're still going to find the slope. So you plug in pi over 4 to the y equation you're given in order to find the y value for the point. So you get tan of pi over 4 minus 2 sine of pi over 4. Just simple plugging in. Not too bad. Okay. So you might be asking, what the heck? Pi over 4, don't know what that is, don't know what to do with that. So you go to your trusty unit circle. And pi over 4 on the unit circle is roughly the angle of 45 degrees. So I'm in a second, and it's in the first quadrant. So I'm going to draw that nice angle. Yep. And the point you get is root 2 over 2, comma, root 2 over 2. That's just unit circle. That's also something you can memorize. But I'm not going to go into it because that's kind of completely different. That doesn't really have to do with derivatives. So you have the x and y value. And remember how I was mentioning in the previous problem, tangent equals y over x. So the y over x of this would be root 2 over 2 over root 2 over 2. So it's basically the same thing over the same thing, which is always 1. And then you get minus 2, and then sine, which is the y value, so root 2 over 2. So 1 minus 2 times root 2 over 2 is what you get your y value to be, which simplified equals 1 minus root 2. Not the prettiest, but definitely not the worst. Okay, slope. So, oh yeah, your point is pi over 4. That's the x value. You were given that. Comma 1 minus root 2. Cool. Okay. Moving on to the slope. Once again, you take the derivative. Very triggy. Remember the inverse of tan and the inverse of sine. You just have to memorize. I know it's not super fun, but the inverse of tan is secant squared x and then minus 2 cosine x. Remember, the minus does not come from the identity itself. The derivative of sine is positive. There's just a negative in the problem. So don't get confused. Okay. So in order to do this, you plug in your x value to find the slope value. So you get secant squared of pi over 4 minus 2 cosine of pi over 4. And you might be asking yourself, like, dang, I don't know how to solve for these. And that's okay because it's hard. So I kind of did a little drawdown that I'm going to show you in a second. I might have to move my screen a little bit, though, in order for you guys to see it. So I'm writing out how to find secant squared of pi over 4. So I'm going to pause it so I can explain what I'm doing. Okay, so secant ultimately means 1 over cosine. It's a fancy way of saying that. So secant squared really equals 1 over cosine squared. So that's all I'm writing out right now. Secant squared of pi over 4, it really equals 1 over cosine squared of pi over 4. So, not too bad. And then, sorry, I'm going a little slow on here. I'm trying to make myself speed up because I did kind of, okay. So, I'm going to let myself write it out. So, 1 over cosine squared really equals 1 over cosine whole quantity squared. Because remember, 1 squared just equals 1. So you can square that and it wouldn't change anything. So those two are equivalent. Okay, so this makes the problem a little bit more bearable because we know how to find cosine pi over 4. And I'm going to let myself keep going because that's actually wrong. This is wrong. So I actually cross it out and redo it. It's not 1/2, it's actually root 2 over 2 because we found the x value of pi over 4 over here. So this is where it comes from right here. So really, I'm sorry, I'm trying to get my hand another way. So really, we get 1 over cosine pi over 4. We found cosine pi over 4 right here. So we get 1 over root 2 over 2. Remember, all of it's squared, so all of it's squared. And it's still all squared. I just simplified this, so basically you just flip the fraction to get rid of the 1 on top. So you end up getting 2 over root 2 squared, which, as I write out in the next part, is really 4 over 2 if you distribute the exponent, which simplifies to a nice 2. So I know that was super complicated. I'm sorry, but that's just how it is sometimes. So you get 2, and remember you still have to do the minus 2 cosine pi over 4. Don't forget about that. All of this stuff was just for secant squared. So, but good news, we already found cosine pi over 4. Remember, it's just root 2 over 2. So you get 2 minus 2 times root 2 over 2. So many 2s, I'm sorry. And then you get, root 2 over 2, which simplifies, sorry, there's so many 2s, which simplifies into 2 minus root 2. Remember, we still have to write the tangent line equation though. That's what we're doing all this for. So, sorry I slid it out of view. But remember the point was pi over 4, comma 1 minus root 2. So you get 1 minus, or y minus 1 minus root 2. That's the slope that we just found, 2 minus root 2. And then x minus pi over 4. I know the equation looks a little messy, but remember it's y minus y. This is the y we found from right here. And then equals slope, which we found right here, taking the derivative and then plugging in x minus x. This was given to us right here. Okay, cool. So we are done with the tangent line stuff. We just have one more problem. Not too bad. Just kind of a mind bender, but not even a mind bender. It's just an interesting question. So we have to calculate the first 5 derivatives of 2 sine x. This is really to demonstrate the interconnectedness and of all the trig identities and the trig derivatives. So we're going to start with f prime. So this is just one of the derivatives you have to memorize. The derivative of sine x is cosine x. Remember, 2 is a constant, so it doesn't matter. So f prime equals 2 cosine x. So f double prime, remember the derivative of cosine, it's negative. So the derivative of 2 cosine x is, I hope you guys know, negative 2 sine x. Cosine and sine flip back and forth, just the matter of negative and positive flips also. So f prime prime prime, or third prime, the derivative of sine is once again cosine. But remember, there's already a negative lingering on this derivative, so it stays because the derivative of f, or the derivative of sine is positive, so this does not get taken away by a double negative. So the f triple prime is negative 2 cosine x. So the next one, the fourth prime, the fourth derivative, so the derivative of cosine, as you know, is negative, so it's negative sine x. But since there's already a negative lingering on there, it actually just turns into 2 sine x. So it just flips back into 2 sine x. And then the final derivative, the derivative we already took from right here, the derivative of sine is cosine. So you get 2 cosine x. Yep. Okay, this is where it gets a little tricky. So now we have to determine the 9th derivative and the 38th derivative. If you think I'm going to make you write out all the way to 38, you are lucky that you are incorrect. There actually is an easier way to do this. As you guys can see, the first derivative and the 5th derivative are absolutely the same. So it's really just a cycle. And so you just have to figure out what 9 and what 38, what number they correspond to in the cycle. So, I'm going to fast forward to where I'm writing again. So it's not too bad. So like, as you can see, the 2nd and the 5th, so f of the 6th. I'm just writing this out to demonstrate the cycle even better. So see, they link. So it's really just repeating itself. So you just have to figure which of these 4 steps does f to the 9th and f to the 38th correspond to, is all you have to know. So what do you guys think? So if the 3rd derivative, or I'll just explain it the way I explained it when I was writing it out. Okay, so the 5th derivative the first derivative equals the 5th derivative equals the 9th derivative equals the 13th derivative. Try saying that 3 times fast. So that equals just 2 cosine x. So it's really just building on top of each other. But if you have a really big number where you can't just work it out linearly like that, like 38, there is another way to do it too. So the way I like to think about it is, so it's a cycle of 4 steps. 1, 2, 3, 4. So you take 38 and you divide it by 4. No, it does not go in evenly. And no, I am not going to make you find the decimal percentage. All you have to know is that it's 9 with a remainder 2. The remainder 2 is really what's so key in this. If it were 9 flat, it would just be this. But since it would, like, this is the beginning, 1, 2, 3, 4, right? 1, 2, 3, 4. Those are the 4 steps. So if it was 0, it would be right here because there would be no remainder. But since there are since there is a remainder of 2, you have to go to the second, or I guess 0, 1, 2, 3, if you want to think about it. You have to go to 2 after the beginning of the cycle. So you would go 1, 2. So the 38th derivative is equivalent to the second derivative, which I'm going to write out in a second. That can be a little confusing. I didn't explain it great, so I'm going to try again. Since there's a remainder 2, you have to go to the second derivative after the beginning. So the beginning, 1, 2, 3. Beginning, 1, 2, 3, right? So the second derivative is equivalent to the 38th derivative. So, cool. So then you find out that f double prime equals -2 sine of x. And I bet you're thinking, thank goodness the video's over. And it is. Thank you guys so much for watching. I hope it was helpful. I really hope you guys got something out of it. If nothing else, to laugh at me. No, I'm joking. But if you have any questions, please drop them in the comments. We can definitely get back to you. Remember that we have lots of other videos if you need any other calc help. And we also have a Discord that you can ask any calculus questions on. And we also have free virtual ACT tutoring sessions. And just thank you guys for watching. I hope you have a great day. Good luck on whatever you're doing. Yeah. Bye. Signing off.